The normal distribution actually comes from a mathematical theorem, meaning that in a sense it's built into the very nature of reality. This theorem is actually called the central limit theorem. And what it means is that if I take a sample from any population distribution and I do that multiple times, multiple random samples, those samples will be normally distributed. Now, that sounds pretty crazy, but let me explain. Let's say my distribution was incredibly unnormal. It was like an extreme binomial. It was only zeros and hundreds. So I could randomly pick from zeros and hundreds. That sounds entirely un-Gaussian. There's no bell curve shape to that. Zeros and hundreds. But if I take a random sample of, say, 50 of those, then on average it should be around 50. Now, it'll be a little bit above or a little bit below, but it will average around 50, even though they're zeros and hundreds. But if I take a random sample from them, then that average of that sample, and I do that multiple times, that distribution that I will get if I histogram all of those sample averages, that will be normal. That will have that bell curve. Most of the values will be within plus or minus 1 standard deviation. In other words, the average deviation from the mean is 1 standard deviation, and most of the values will be centered there, and that'll give you the hump shape of the bell curve. And then outside that, exponentially they'll tail off. As you get further away from the mean, it's very unlikely. So if I took the 50 samples from the zeros and hundreds, it's extremely improbable that I'll get all 50 hundred or all 50 zero. It's more likely that I'll get about half and half of each, so that the average would be around 50. So that's why it's called normal. It's literally a theorem that means that this is somehow built into the very nature of reality. So it's really cool. And if you love statistics, man, you gotta love the central limit theorem. Thanks. Bye.